I'll start recording for everyone who's going to be watching remotely. We didn't really get to have our fun pre-lecture interlude because I was in that meeting, but we do now get to have the fun lecture, right? So without further ado, I think I'll go ahead and get started. I still don't have a solution for my headset turning off every 20 minutes, and so I'm looking forward to that. But are there any questions before I get started? I'll keep an eye on Twitch chat. Sometimes I like to answer some questions pre-lecture. I know we didn't have that choice, so if you do have any questions, about last lecture, homeworks, whatever, just throw it in Twitch chat, and I'll see it. Obviously, the Twitch chat channel and the Discord. Maybe we should call something else. So let's talk about our objectives for today, right? On Tuesday, we talked about backend 1, and kind of following our pattern, we did front end 1, front end 2, backend 1. Now we are doing backend 2. And so we're going to be doing a little bit of a review for front end 1, more than we normally do, and so I listed it here. We're going to be doing some advanced templating. And so last lecture, we just saw a very basic example of templating, passing some variables to a web page and, seeing it there. We're going to be looking at that in much, much more depth. And then we're going to take a step back and we're going to, kind of take a step away from code for a little bit, and we'll talk about more general stuff that, you really should know if you do decide to work in front end. And so we'll talk about this thing called the request and some objects that you can interact with when it comes to what the user is trying to do. And then we'll also talk about kind of the trade-offs between server and client side. And, this part here, the server and client side discussion, I want to be more of that, more of a discussion. And so it's something a little bit new that we're going to be trying, just kind of focusing more on the discussion part. I know not everyone watches these live, and so it might be a little bit interesting. Hopefully it'll still work, but nonetheless, we'll see how it goes. So let me just get this last little thing set up. One watch and okay, wonderful. So I hope your week has been going well, and we'll go ahead and get started for realsies. So let's start with review. On Tuesday we learned how to make a basic Flask server. We learned about basic routing. What is a route? What are these things doing? We learned about rendering and templating HTML pages at a very basic level, and then we learned about serving static files. So how do we make a Flask server? Well, step one, import Flask, right? We make the app that Flask is going to be running on, and you can think of this as the server itself. And then we start building the routes for our app. And the way that we can read these routes is when someone goes to this URL, I want to route them to this function. I want my server to execute this function. And so we execute this function, and again, this can be named whatever. It's just basically a normal function, and I'm going to eventually return what I want to display on the page. In this situation, we have hello world, but maybe you want to render an HTML page. Maybe you want to send them data. If we are certain that this is maybe execute route index.html. If we're certain that maybe this is, someone who's just trying to collect data from us, or maybe this is an endpoint that we've built so that people can, receive data, then maybe we just want to send them back data. That's definitely a viable option. So let's talk about routing. Routing is how we define what URLs should do what. Variables and variable routes are surrounded by the angle brackets, if we remember that. Variable routes being you build one route for maybe many, many things. And so an example of that is maybe, user accounts is a very popular one. And so if you want to view your profile, maybe you go to, I guess for Twitch, twitch.tv/CS196 Illinois, right? I can tell you that's a variable route in the back end of CS196 where they're taking the account name and working from there. So we have the structure of a route being the decorator, which is, whoops, wrong way. The decorator being this at app.route. We have the function name and any parameters we're passing into it. We have the function body. Actually, yeah, you're supposed to be seeing slides. That hurts. So, objectives for today: review advanced templating requests, server and client side. That was production quality. Oh, that hurts. I'll just kind of briefly go over what we weren't seeing. So we talked about how to make a Flask server, the import, the app, the decorator, the function, the return. Um, how we define the URL should do what. Variables and variable routes are surrounded by these angle brackets. We have the structure of a route being this. Yeah, that's a big production quality minus minus. We have actually the rendering of HTML pages. And so if we remember, Flask allows us to kind of execute some code inside of our HTML document before we show it to the user. Just to be clear, this is an actual Python, and we're going to really dive into this today. We do this by wrapping the area we want to execute in double curly braces, or as we'll learn today, single curly braces and a percent sign, and we'll see the different uses for those. Don't forget that you need to pass any necessary parameters to your web page as keyword arguments to the render template function. And so we'll say render template myname.html, and then we'll say keyword argument name equals William. Don't forget to put your templates in a templates folder. And then finally, we'll learn some advanced techniques with this today. I would like to close the thing that is binging Messenger tab. So we'll learn some advanced techniques with templating today. Yeah, it was Messenger. I closed it. Additionally, we learned about serving static files. Flask allows us to serve static files. Often this is images, CSS, JavaScript, stuff like that. We can do this by placing them in a static folder and calling the URL for static file name equals, whatever file name inside of the HTML. And again, because this is templating, this will get resolved down to the actual file path of this file. So let's kind of get right into the content for this lecture, which is advanced templating. And so not many people write HTML directly anymore. It isn't very common that you open up an HTML file and just start typing, doc type HTML, HTML tags, head, body, etc. It's much easier to utilize some of the advanced capabilities and advanced abilities that templating provides to us. With templating, our HTML files can use stuff like variables and expressions that we saw in the past. We can do filters in control structures, which we'll learn about today, and we can even do very, very powerful stuff like blocks and macros. Blocks being kind of a key part of templating. We'll explore that for a very long time. So what these are going to allow us to do is make our HTML documents from a static page to something that's dynamic and modular. And so let's think a little bit about what these two terms mean. So dynamic being the HTML page can change based on whatever state we're in, the user that's trying to access it, the time of day, the phase of the moon, whatever we want it to be. And then modular being if we have maybe a single component on many pages, then can we avoid going to each one of those HTML pages that has it and changing it in 5, 10, 20, 100 locations and instead just change it in one? Right? I think maybe a great example of this is think if Google wanted to change the logos for some of their services, like Google Drive. Well, how many websites have the Google Drive logo somewhere? Right? Countless. And so if we keep it modular, we can change that in one spot, and they are all getting it from the same location. So we can show the value. We'll talk first about variables that we looked at yesterday. We can show the value of a variable on the HTML page using these double curly brackets and then the variable name. Again, just make sure to pass this variable name as a keyword argument to the render template function. We can look at an example here. So we'll build our route, and we'll have a variable called myname. We'll return render template templating.html, and we'll have the keyword variable name, keyword argument name, be equal to my name. And then inside of our HTML document, we'll just print out this name, and we can see it here. So one small thing that I want to note is keep in mind, or at least pay attention to, this variable out here is called my name, and when we pass it in, we're calling it name instead. This is totally fine. You can call it the same thing, you can call it different things. All of those are okay. You do have to do these keyword arguments though, so do keep that in mind. Or at least you very much should. It's very good practice. So the next thing is expression. So we can execute some code in our HTML. One thing that I want to note is this is not Python. You cannot do anything that you can do in Python in an HTML document. Unfortunately, you can do a lot of stuff, but there are limited kind of functionality. You can't start implementing classes and functions in here. So let's look at some of the valid expressions. These are not all, but of course, if you ever do want to know, more valid expressions, the doc's the place to go. So we have literals being strings, numbers, lists, true, false, Boolean values, any of those things, right? Additionally, we have math, and so we have plus, minus, divide, power, star, or multiplication, floor, things like that. We have logic, and so we have, equals. So we have comparisons like equals, not equals, greater than, less than, or equal to. We have things kind of more logic focused, not, and, or. And then we also, if we remember from Python, we have in, being is this element in the array, right? So we'll look at a quick example. We have staff names here, Eustis, Matt, Albert. We'll pass this as a names keyword argument to our HTML document. And then we will print out Eustis in names. So what does this do? Does the literal Eustis exist in the list names? Well, if we go back here to where we defined it, yes, Eustis is in this, and so this returns true. Hopefully this makes sense. If not, again, feel free to ask any questions. So let's learn about one of the new tools that we're going to be kind of introducing this lecture, and this is going to be filters. And we'll see some examples of this as we go, but let's kind of dive into it just for a second here. So filters allow us to modify variables, and this structure is not really something that we've seen before. You have the variable name here, and then we follow it by a pipe, and then the filter names, and we can chain these together. There are specific valid filters like absolute, sum, round, sort, int, max, things like this, as well as some more string-focused ones: join, upper, replace, reverse, things like that. I guess some of these are also lists like join and reverse and sort, max, sum. So these are all just kind of, little Python built-in, often Python functions that, normally we kind of take for granted. We have to implement these in a little bit of a different way. And so we'll look at a quick example. We have staff names Eustis, Matt, Albert. We'll again pass this the same as the example we just looked at, and then we'll say hello, names, sort, join, comma. So let's analyze what's happening here one at a time. First, we have the names variable, which is Eustis, Matt, Albert, a list of Eustis, Matt, Albert. Then we sort it. This takes no parameters, and so we can just type sort. So we're going to sort this because they're strings alphabetically, and so the list becomes Albert, Eustis, Matt. And then we will join the elements in the list by a comma and a space. And so this basically just will turn it into Albert, comma, space, Eustis, comma, space, Matt. And then again, if we think back here, we appended this string literal to it. And so this will eventually get templated down to hello, Albert, Eustis, Matt. Maybe if you wanted to get fancier with this, you could, insert an and there by doing some indexing, but we won't discuss that now. So additionally, we've learned about templates. Let's learn also about control structures, which allow us to control the flow of the rendering. And this is the first time that we're going to see this curly brace percent sign. Generally speaking, this curly brace percent sign is used for maybe more operation-focused things rather than content itself. And so valid control structures generally are if and for. There's more things that count as control structures. In fact, many things count as control structures, like blocks we'll see later. Even filters count as control structures. But in our situation, we really care the most about if and for. One, significant difference when compared to Python is we have to close these. And so if you have an if expression, you have to eventually have an end if. Right? This is because HTML is not, indentation specific. Python, we really care about the indentation to keep track of our scope. But in HTML, that's not really a thing, and we can't enforce that. So instead, we rely on this end if to decide when the loop ends. You may ask yourself, why can't we make this much simpler with like an open curly brace and a closing curly brace? Well, they didn't implement it that way, so we're not allowed to. Again, for fors, same thing. We have for variable in list, just like in Python, and then less like Python, we have the end for. So let's look at a quick example. We have numbers 1, 2, 3, 4, 5, 6. We will pass this as data to the website. We'll say for data point in data, if data point mod 2 is equal to 0, then print data point. And if end for. And so, of course, we iterate through this. Data point is 1. 1 mod 2 is equal to 1, and so this is not true, and so we do not include this h1 tag, and we try again. Data point is equal to 2. 2 mod 2 is 0, so we print data point in an h1 tag. We can see that here. 3, 4 gets printed, 5 gets ignored, 6 gets printed, and of course, that's the end of our list. So a little bit, different structure for stuff we're doing here. But, if you are interested in kind of developing in web dev, this is, kind of valid and important things to use. So we'll have a quick interlude. We've learned about variables, we've learned about expressions, filters, control structures, and so now our HTML pages are dynamic, right? They can change. We can have a for loop. We can print out 1,000 cards, and if we change the list in our database, we can make it 1,001, right? But they're not really modular, right? If we have the HTML code for a navbar, there's really no easy way to serve that to all of the pages at once, right? If we have a menu bar, is there an easy way to change it on many, many pages at once? Well, maybe we generate it in the back end and pass the HTML as like a string to the front end. Is that scalable? If we have a million visitors, how much slower is my server then going to become, because it's generating these probably very long or very many strings for every single part of my website that I want to be modular, which might be a huge portion of my website. So maybe that's not such a great solution. So instead, let's have a quick quiz, and then we'll start to get into how to make this modular. And so I will go to bot commands. I have to remember all of the commands. And then we do this. Okay, you should all see the quiz in Polebot now if you want to go react. I'll give it probably 45 seconds. Well, I'll give it a minute. So until 7:19. Additionally, at this time, feel free to ask questions. How would we do this? Why are these things this way? Things like that. So hopefully everyone's going to the Polebot channel and reacting to this quiz. Maybe we'll talk about it together in a minute here. A minute was too short. I'm doing 2. So let's start to discuss this maybe. So again, we'll just kind of take this line by line. First, we have app.route index for the get and post methods. We didn't look about this last lecture, and we'll talk about this more later. But basically, this just means, only do this if it's a get or a post and not one of those other things. So next, we'll run this hello world function. We'll create a data and my names variables lists. My data being 0, 1, 2, 1, 0. My names being Eustis, Matt, Albert. We'll pass these both to the template as data and names. We'll iterate over data. We'll say if the data is even, then print out names of data point. And so let's analyze what happens here. Well, first data point is 0. 0 is even, so we take names index 0, which is Eustis. The next one is 1. Data point 1 is odd, and so we do not print this out. The next one is 2. Okay, I'll close the poll at this time. Wonderful. Okay. So the next one is 2. 2 mod 2 is equal to 0, and so we take the index at 2, so that's not Eustis, it's not Matt, it's Albert. And so far we've printed out Eustis, Albert, and I'm sure you can see where this is going. The last one, 1 is odd, so that does not get printed out, and then 0 is even again, and so we take Eustis. Some people said, one, we are taking this if statement here, and so this won't necessarily get printed out because all of the odd variables are filtered out essentially by this if statement. Additionally, some people said, two, no. I think Matt probably said two, if I had to guess. Yes, Matt. Unfortunately, Matt is not the only thing that is printed here. He's the only thing that's not printed. So sorry, Matt. Okay, so let's kind of start some of this discussion. I'm interested on why my headphones haven't died yet. It's been 20 minutes, or not died, but turned off very briefly. So expect that in the near future. Um, so let's start our discussion on some of the really kind of powerful tools with templating, and that's going to be blocks. And what blocks allow us to do is to predefine an HTML structure. This is referred to, again, Jinja being the templating engine that Flask uses. This is referred to in the Jinja documentation as, quote, the most powerful part of Jinja. So let's look briefly about how this is used in these HTML documents. And so once again, we have these curly brace percent signs. We have block, block name, and end block, block name. One quick note is you don't actually technically have to have the block name on the end block. That part is optional. However, it is very good practice, and I very much do suggest that you have it. When we use these blocks, we rely on this new thing that we're about to learn about called HTML inheritance. And so what we're going to see soon is HTML pages essentially importing one another and extending one another, similar to, kind of this polymorphism that you've seen in, hopefully, CS125. So we'll kind of just explore an example here. So first we have the template, and again, think of this, in the past we were using this as the content of the page itself, right? This is what we were printing. I want to change our thinking a little bit. And so when we start to use blocks, really the purpose of these HTML templates with this head, body, content, HTML stuff changes. It is no longer really the content. It is the skeleton. It is what we want to fill with content, what we want to push our content into. And, an easy thing to think is you basically have this same exact code for every single HTML document you'll ever write. Right, but what we want to do is fill these different sections with different things, depending on the different pages. And so other pages will import this structure and fill the blocks with content. And we have this, and this is called the base template, the very first template. The important thing to note is it does not have this extends line that we're going to see in these future ones. So now let's look at this extends line. Let's look at this child template. And so the number one thing, the kind of most critical line is this extends line. And so what this does is it says, hey, take all of the information that I'm about to provide and put it into the templating.html document. So we can see here that we define this block content, we put a div in there, and we end the block content. So, and again, when we are taking this from the compiler side, when we're serving this web page to our users, what happens is the web page goes here and it says, okay, well, let me take this and let me fill block content with that. And so it basically just copies this part and places it right here. So this defines the content that we want to fill the base template with. The child template defines the content we want to fill the base template with. That's a very important property, so try to keep that in mind. We select which base template we use with the extends line up here. We can have multiple base templates, and so maybe you only want to use, you can't have multiple ones for the same file, but we can have multiple ones in our file system. Maybe different pages look different ways, and you only want to extend a specific one of those, right? You select how to do it right there. So I'll take a quick question real quick, some audience interaction. Which of these pages do you think we're going to try to render with our render template? So let's say that the user gets our page. Which of these two pages are we going to give the string to render template when we say return, render template my document.html? Which of these two pages do you think? Okay, yeah. So it's we will render the index.html document, and that's because if we look at this templating.html document, it actually doesn't know that this index.html document exists, right? And additionally, if we think about this, more kind of take a step back, many things can have this content, and so even if maybe we did try to search our file system for things that extend this block content, we may find many things that do that. And so it really does make a lot more sense to extend this index.html, and then that will get, kind of filled, or that will fill this template. Um, this is a little bit of a strange way of thinking, right? It doesn't, I think, feel natural to render this page instead of this page to the user. It feels a little weird. However, that's just the way that these things are, and so we kind of have to learn it and get used to it. And so let's look at a little bit more of a fancy example. So blocks don't necessarily have to be one level; they can be hierarchical. And so, we'll take an example. We'll say all of our pages have a Okay, we'll say all of our pages have a nav bar, a footer, and some content. But only some of the pages have an article title and then the content of the article. And so let's see how we may be able to implement that. So first we have the navbar block, we have the content block, and the footer block. And again, everything has a navbar, everything has content, everything has a footer. Right? We don't know what's in those necessarily yet, right? Maybe we want to define those somewhere else, but we know that everything has those. And so next, we'll start to actually populate that navbar content in footer. And so what we'll say is this extends templating.html, which is this document here. We'll define this navbar block just to say this is not my navbar. We'll define this content block to be filled with content. And inside of this, we'll actually have a block, another block for extra content, right? This is just kind of the general content for the page, and this is maybe the specific content for the page we're trying to load. And then we'll also make a footer, just being kind of a basic footer. Additionally, I will mention, you may have seen me pass over this block style. You can have blocks in the head, and in fact, we won't see it, but you can put style tags here and write CSS inside of that. I don't list it because the style tags are kind of long, and I just use them to help visualize things in the future eventually. But I would put those in this index.html here. It's like 30 lines or so of just like CSS, making things, putting things in the right location, making them have a background, making them the right width and height, stuff like that. So additionally, let's think of a specific page to this blog.html document that will extend index.html, being this document here, which extends this document. And then we'll fill this extra content block with an article title and, a blog post in that article title. And so extra content block gets fed back to the content block, which gets fed back to, this content wrapper here in the body. So let's really look at this step by step. So what we're going to do is we'll render this blog.html, and it will say, okay, I'm extending this templating.html. And then that will say, okay, it will extend index.html, which will extend templating.html, and then we'll kind of just start reading these lines line by line. And so, doc type HTML, HTML head, we have the style tags, which again, I will mention, it's there, it exists, but it's just a little bit too long for me to put in the slides here, so we're going to pretend like it's not there. But just know there is, CSS being written there. And then we'll kind of start the exciting part. So we start in our body tags, we hit this blog nav bar, and this whole thing is being imported from here. And so we say, okay, well, blog nav bar consists of this information. And so I'll take this div, this content, and this closing tag and place them directly in the body here, and then go back. Additionally, then we'll make a div for content wrapper. We hit the content tags. The content tags go over here. We make a div. We put some content in a different div. And then we have extra content. Well, that takes us to this file in here, right? We read the content from here, making the div in the h1 tags. We go back out to here. We close this div, and then we go back to the original doc. Next, we'll look at the footer, and again, kind of the same process as before. We hit the footer block, we go to where that was implemented, where the document that extends it, we, parse the footer information and put that into the thing. I feel like I'm about to sneeze. And then we'll end that footer block and return to the document. We close the body, we close the HTML. And so hopefully maybe this gives a little bit of insight into the flow of things. And it's I understand that it's weird to think of because we're not serving this templating.html document. We're serving this blog.html document all the way over here. And so how it does this is a little bit strange, right? You kind of go from here to here to here, and then you kind of go back when you're printing the things. But that's how it's implemented, and that's how it works. And so if we're doing front end development, so it would be a div inside of a div for the content wrapper. Yeah, let's analyze that. So, Navbar doesn't arbitrarily open a div, and so there's nothing fancy there. Then we have div ID content wrapper. We go to block content. Then we have div ID content. And then inside of that content, which is inside of content wrapper, we have a div that is closed. And then as brothers, or as siblings, I should say, we have the h1 and the div tags. And so we only have 4 layers of divs, it seems. We have div content wrapper, div content, this div for the content, and then this div for the blog post, right? These two, this h1 and this div tag, are not inside of this div here. I know it maybe would have been a little bit more clear for me to put this on a new line and keep the indentation pattern, but I hope you can see how it's only 3 layers of divs instead of 4. If not, I can go over this in maybe some more detail. Sorry okay, great, awesome. So let's look at what this looks like. Well, we have our nav bar at the top, and again, don't worry about the positioning and the colors. This is just for visualization. It was what was in those style tags. We have the nav bar, the content for the page, the article title, the blog post, the footer. So, and let's kind of break this down, kind of going back and forth. So first we have the nav bar, block nav bar. We get that from here, right? Next we have the content wrapper, and so there's a div that goes around this content. Then we have the content inside of the content wrapper. And that's what we get right here. Then we have a div for the content and an h1 in a div for the article title and the blog post. Here, here, and here. Then we close this div down here, and we have a footer as well all the way down here. So let's discuss kind of our next topic very briefly, which is macros. And macros, I think for me, are maybe a more natural way of doing things, personally at least. So macros are like functions, which is you say, you pass a macro some parameters, and it will return to you some HTML. And so we'll say macro name parameter 1, and macro, or you can have parameter 1, comma, parameter 2, 3, 4, however many. Name just being the name of the macro. And then we'll call that macro. We'll call name and pass whatever parameters we want to it. So let's look at a quick example. So, okay, so first we will create our macro here. And again, I will mention, we have to have end macro and end call, just like many, many things. So we create our macro here on line 8. I'm trying to remember. Oh, I remember how I wanted to do this. So yeah, we create our macro here on line 8, and we define this block to be like what should happen when we do a macro. And then we'll call the macro on lines 18, 19, and 20. And so let's say we render this page. What happens is, we go through HTML, lang, blah, blah, blah. We get to the body tag. We get to these macro tags. We define this, but we don't do anything with it yet. And then eventually we get down to this call tag. And because we're saying call list, and we have a macro called list, we'll actually execute this. And so we hit this call list item. We build an unordered list, and then for every item in the array, for each item in the array being the parameter that we passed in, we can see it here, list array, and we can see what the values are here, 1, 2, 3, 4, 5. The first item, of course, is going to be 1. Caller. So we build a list item, and then we do this thing called caller. What is caller? Well, caller is, I think, a necessary thing that you have to use with macros. And what it does is it takes whatever is inside of this call tag and places it there. You could have nothing there if you wanted, but I do think you have to call caller. I wasn't able to ever get it to work without calling caller, and all of the docs always use caller, but they never explicitly said that you had to use caller. So it was a little bit of a weird case there that I wanted to mention. So what does caller become? Well, caller becomes the text list item. We convert that to a string. It is already a string, but we'll convert it to a string just in case. Again, this is using a filter. We learned about these before, just earlier in this lecture. Next, we'll have item. Item being 1 right now, we'll convert that to a string, and then we'll move on. We'll close the list item, and we'll go to the next item in the array. We do it with 3, we do it with 4, 5, and then eventually we close the unordered list. We end the macro, we end the call, and we continue on with our lives. And so, what should this print? Well, what did we create? We created an unordered list, and then we created 5 list items that say list item 1, 2, we'll say list item 1, 2, 3, 4, 5. Then we close the unordered list, and we have our body closing tag. So if we go to our document, our HTML document, we can see that that is in fact what we get. List item 1, 2, 3, 4, 5. Again, these bullet points are reminiscent of an unordered list and list items. And again, I know we didn't necessarily discuss unordered lists and list items in our front end 1 lecture, but with things like this, Google it, right? You hopefully should be comfortable kind of seeing things that you've not been exposed before because, we're all smart cookies and we can Google what is UL HTML tag, right? Your honor students, the best of the best. So that's most of our discussion on kind of blocks and macros and templating and things like that. I actually do want to take a second and go way back. Look at how many slides we just went through, crazy. And just make sure everyone's good on this stuff. If again, this is kind of one of those topics that to some of you it may not be super applicable, but nonetheless you are honor students, you are taking CS196. I am here to teach you about cool stuff that you won't know otherwise, right? And I think HTML templating and web dev in general is one of those things. Whether you're going into systems programming, embedded development, machine learning, CS theory, being able to share your work and share yourself, with portfolio pages with others is something that's a critical skill to have, especially in computer science. And so, the internet is a huge thing, and being able to develop a website to share your work or share yourself is a critical step in doing that. And if you want to save yourself a lot of headache, this is the way to do it, is with templating, especially if you have many pages. So if there's no questions about blocks or macros or things like that, we'll move on. Again, these lecture content, these are always recorded, and all the slides are online, so on the CS196 website if you ever need to review. So let's talk a little bit about the request. And again, we'll be taking a little bit of a step back here. We'll be talking more generally for the rest of the lecture. We won't necessarily be looking at as much code. So hopefully, take a deep breath, relax. We're through the complex block examples. And so let's talk a little bit about requests. So requests are stored in the request object, and they have categories of attributes. Requests and responses, for that matter, which we will not discuss in as much detail right now, are massive objects, huge objects with many properties. But we're going to look at some of the categories, and then we'll break down specifically this common request data category. So we have the common request data. We have header parsing attributes. These are things like what languages the client supports, what encodings the client supports for text, like UTF-8, things like that. We have entity tags, which are generally used for cache information. And so the important thing here is, maybe you have many images. If you ever complain about why Chrome takes up so much RAM. Entities and caching is a huge part of that, and it is frankly what makes Chrome so fast as well, right? If you load a web page one time and you have to download all of these, images and JavaScript and CSS files, when you navigate to the next page that uses those things again, you don't want to have to re-download them. You should use the ones that you already have, right? And so, these store them in the cache as well as other things in the cache. We have the user agent data, which is, what type of computer they're using, what type of browser they're using, things like that. We have authorization data, which is like username, password authentication responses, and so on and so forth. I will note, if you're doing less secure password handling, the password's raw string could be in this authorization data. Generally speaking, that's frowned upon for obvious reasons. You almost never ever want to have a password in raw text anywhere ever. Um, and so instead, we have this password authentication response, which is essentially some, hash that's saying, the password was good, the password was bad. And, if you want to work with authorization data, maybe this is the way to do it. I know there's other libraries that will handle it for you. I know Google's OAuth does a very good job, and so maybe you'll just end up using that. But, again, I'm kind of just hoping to expose you to some of these concepts. So if you ever are faced with, I need people to log into my website, and you want to do it by hand, you know where to go. There's also CORS data, which stands for Cross-Origin Resource Sharing, which is maybe a long and complicated acronym, but we can break it down. Cross-origin being across different origins, across different URLs. Resource sharing being sharing resources, often static files, but not always. Basically defining where you can and cannot load things from. This is basically a security thing. I don't want to load things when someone visits my site from untrusted sources. So let's break down the common request data. First, we have the arguments being just, the things in the URL that are parsed out. Additionally, there's like 4 different versions of this arguments being, the parsed version in a dictionary, the parsed version in a different type of dictionary, the raw string, the string, but also parsed somehow. It's very strange. Just use whichever one is best for you if you ever do need to use it. All of the cookie information, obviously, you are all avid, probably internet users. You're all CS students and you're watching this on Twitch. And so every time you visit a website, they ask you, hey, can we use some cookies? Well, cookies can be many things. It can be storing your login information so you don't have to log in every time. It can also be storing your browsing data so that they can sell your data to AdSense providers. It can be many things, but you can write your own cookies to be whatever you want. And basically, you can think of cookies as just, a little bit of information about the person that's visiting that page, right? Past history of what they've done, things like that. Uploaded files are in the request data, and so maybe if it's a post request and they have just filled out a form and uploaded a file, this is where that information lies. Form response information, following a similar train of thought, if they have filled out a form and submitted it, this lies in the request data. Because again, think about it, they're making a post request, right? So all of the information we need for a post request should live there. There's lots more in the request data kind of category of things. We're not going to go over them all. Hopefully you all are comfortable enough where you can think, okay, well, this thing that I'm looking for probably lives in this request data, and I'll go look at the documentation for it. So we'll think of, I do want to just list one very common usage of a common request data, which is the method of request. We'll say if request.method equals post. One note, you do have to import request, so just keep that in mind. And what this does is, we have this code over here to handle if it was a post request, and this code over here to handle if it was a GET request. And, really, I think great and easy to understand application of this is a login page. The GET request is when you want to give them the page to log in, and the post request is when they have filled out the form and they have chosen to submit their login information, and you want to actually check if they exist in your database. So let's quickly discuss kind of web development, server side versus client side. It choosing to do some computation or some data request on the server side or the client side is something that you're going to have to choose to do a lot. The server side being, essentially in your app.route, the client side being usually in JavaScript on the page. So, this is a very long discussion, and so we hopefully can just discuss a little bit about maybe some examples and analyze the pros and cons. But really it does kind of come down to a case by case basis. We'll look first at client side. The more you do client side, the less you have to pay for server costs, which is good, especially if you have many users. If you don't have to pay for server costs, you are saving money, obviously, right? And the reason for this is anything that your server is going to do means that you are paying just a little bit for the time that's going to take, right? Obviously, if it's one thing, that doesn't matter. But if you have 10 million, users every day, or however many Google has every day, very small things can really add up. If the user is self-sufficient, being if the user has everything they need on the web page, it can drastically increase web responsiveness, right? You can think for trying to think of a good example, maybe for yeah, I can't think of a great example off the top of my head, but anytime they want to interact with something on the web page, they don't have to wait for server data every time. One kind of classic example, a newer kind of paradigm in front-end development, is this thing called single page applications, or SPAs. What those are is you give them a single page and a ton of JavaScript, and when they click on index.html, the JavaScript actually changes all of the information on that page itself. And so it doesn't even touch your backend, which is very nice because you save a ton on server costs in that case. And your website is also generally very fast, uh, unless they have a slow device, right? The cons of client side is you obviously can't give sensitive information to users. You cannot give them API keys. You cannot give them access to your database. And so that is not an option. Do not do that. I guess theoretically you could, but you will have a bad time. Additionally, some devices are maybe too slow to perform advanced analysis or calculations or data processing or rendering for that matter, right? If someone's loading your page on a Raspberry Pi, 5 miles away from the closest cell tower and they're on 2G, I think Raspberry Pis have cellular support with like an add-on board. I don't know. Anyway, that's going to be not so great for them because it's going to take a very, very long time to load. And, especially if you're doing something like a single page app and you have many megabytes of JavaScript, it really, really could be, 10, 15 seconds before they're able to load your page, which is not a great user experience. And then we'll talk about server side. You have tons of control over what you're sending to the user and when. You're basically able to send them exactly what they want and nothing else, which is handy. You can access sensitive and permanent databases. Generally speaking, nothing you access on the client side is going to be permanent. Cons, you have to pay for servers, and the user, this is a big one, has to wait for your server's response. And that's generally pretty slow, often slower than what it's going to take for the user's device to load it. So just do keep that in mind. So we'll look at some examples. You want to host a computer vision model on a website. Well, some questions we have to ask ourselves: is it small? Do we think it can run on small devices? Does this computer vision model need to run in real time? If so, client side could be better, right? If it's using their webcam and doing something in real time, we kind of have to do a client side, or else it may be prohibitively slow to upload an image to your server, perform some computation, send it back. If the model is large, or if the model is slow, or if the model is proprietary, you trained this, you don't want anyone else to have it. If you want it to run on client side, you have to give that to them. Then you may have to use server side. Retrieving account information. Client requests server, server accesses database, server returns only the information for that user, client displays it to the user. User wants to play a game. So, does latency matter? Then we may not be able to do it server side. Does security matter? We may not be able to do it client side. So, if we have a single player game, generally speaking, it's going to be client side because, we don't really have to worry about security and we just want it to be fast. With stuff like chess, right? Chess.com, Chess, whatever, what do we think they use? And this will be kind of the last question before we end lecture. What do we think something like chess.com uses? Well, we can ask ourselves things like, does latency matter? A little bit, and it doesn't not matter. Does security matter? A ton, right? A ton. If we're doing this on the client side, we have to imagine that the user can do whatever they want to it, right? They can change that code and execute it and send a move that may not even be possible, right? Um, and so we have to worry a lot more about security in that case. And so, generally speaking, yes, chess.com will use client-side processing, right? Server-side to display all of this stuff and move your pieces around easily and be able to interact with the page easily. And then once you choose to move a piece, we are sending a request to the server saying, post request, hey, I moved this piece to this location. It updates some internal game state, and then it says, okay, you moved that piece to that location. Okay, well, this was Backend 2. Thank you all for kind of coming to this lecture. I hope that you enjoyed it. The next two lectures will be on databases, and then I believe we'll have a class favorite internship or class favorite lecture on kind of the basics of getting an internship and how to sell yourself and apply and things like that. That's a very good lecture. We get many notes in the future. I think Sammy got one recently about how someone has recently received an internship at Capital One, and that lecture was great for them. So that's a real favorite. Hopefully, you guys will have a great time with that. After the internship, we'll have my favorite lecture, which is machine learning. And so hopefully, all of you ML people who have been suffering, maybe hopefully not suffering through the web dev, will look forward to that. But databases is the next step, and so we'll be learning about and implementing our own database, which is a very, very good, useful tool. So thank you all so much. I will see you on Tuesday. If you have any questions, I'll hang out in Twitch chat for a little bit and respond. But thank you and goodbye.